In this problem, my relation R6 has two elements, and those are 0, 1 and 0, 2. So I'll draw my directed graph for those. Arrow from 0 to 1 and an arrow from 0 to 2. Now we'll check our properties to see if this relation is reflexive, symmetric, and transitive. So, is it reflexive? Well, if it were, then I'd have to have the element 0, 0, or 1, 1, or 2, 2, or 3, 3. And I don't have any of those. So I'm going to say no. And then I'll just say 0, 0 is not an element of R6. There you go. That's all we have to say. Now, determine whether the relation is symmetric, and this will possibly and probably surprise you, is that this is symmetric because, oh, it is not, sorry. I just jumping ahead. So it is not symmetric. Of course it's not symmetric because, so I'm going to say no, because we have, take either of them, 0, 1 is an element of R6 and 1, 0 is not an element of R6. So it would have to be 1, 0 would have to be an element of R6 if the relation were symmetric. Now it's the transitive one that's going to surprise you. So transitive, is it transitive? And so what we have to check for transitive is if there is an element 0, 1, and then we'd have to have 1, something, then 0, whatever the something is would have to be in R as well, or R6. Now, is this the case? Well, we do have 0 going to 1, and then nothing comes out of 1. That's not going to happen. So I can switch it. Let's see, I have one more element. So I can do 0, 2, and then it's 2, whatever. And do we have 0, whatever? So there's 0 to 2, nothing coming out of 2, so that blows that. So, is the relation transitive? Yes. But there are no ordered pairs that satisfy the transitive property at all, which by default makes it transitive because you'd have to have something that contradicted the transitive property or showed that the transitive property was not holding. So by just having nothing to make into a transitive type property, so this is basically yes by default. It's the best way to describe that. And that's how you do that problem.